Good day everyone, in this video I'm gonna show you my own example in solving differential calculus. Solving the derivatives of trigonometric function, logarithmic function, exponential function, and maxima and minima. First we're gonna solve for trigonometric function. My own example is sin x plus tangent x over 2 sin x minus 4 cosine x. First, we're going to simplify this equation. Tangent x equals sin x over cosine x over 2 sin x minus 4 cosine x. Then we're gonna simplify this expression. Write all numerators above the denominator. Cosine x over 2 sin x minus 4 cosine x. Then simplify this complex fraction. Cosine x sin x plus sin x all over cosine x times 2 sin x minus 4 cosine x. Then distribute sin x. Cosine x sin x plus sin x over 2 cosine x sin x minus 4 cosine x squared. Then simplify the expression. F of x plus d over dx cosine x sin x plus sine of x over sine 2x minus 4 cosine x squared. Next is use the differential rules. F of x, f prime of x, d over dx equals cosine x sin x plus sine x times sine x sine 2x minus minus 4 cosine x squared minus cosine of x sine x plus sine of x times d over dx sine of 2x minus 4 cosine x squared all over sine of 2x minus 4 cosine x squared. Then f of x, f prime of x, d over dx plus negative sine x plus cosine x, then cosine x plus cosine x times sine 2x minus 4x. cosine of x squared minus 4 cosine x squared minus cosine x sin x plus sin x plus sin x plus sin of x cosine 2x minus 4 times 2 minus cosine of x times negative sine of x all over, sorry for the waiting, sine 2x minus 4 cosine x squared. Then simplify the answer. F prime of x d over dx equals negative 4 cosine of 2x cosine x squared plus cosine x sine x sine 2x minus 4 cosine x cubed minus 2 sine of 2x squared minus 2 cosine minus 2 sine of x, 2 cosine of x minus 2 sine of x, 2 cosine of x minus 4, 2 cosine of 2x minus 4 sine x sine 2x all over sine 2x minus 4 cosine of x squared. This is the final answer. Next is we're gonna solve for logarithmic function. Derivatives of logarithmic function. Here's my own example. Y equals sine x raised to the power of 2x. First step, we're gonna solve for the natural logarithmic of both sides of the equation. Ln sine x raised to the power of 2x. Then apply logarithmic property. Equals 2x times ln sine x. Apply the logarithmic property here. D of x to sine 2x times sine of x. In here, we're gonna differentiate the implicity for number y. dy over dx 2x times cosine x over sine x plus ln sine x times 2. Then 1 over y times dy dx 2x cotangent x plus 2 plus 2 ln sine of x. Then solve for dy dx. We're gonna solve for dy dx here. Dy dx equals y 2x cotangent x plus 2 sine x. We'll start here to solve for dy dx. Dy dx was sine x 2x cotangent x plus 2l sine x. Now here's the final answer. Next is exponential function. Here is my own example. 12 cosine x plus 2x cubed. 12 raised to the power of cosine x plus 2x cubed. In solving this function, we're gonna use this formula. Y prime equals AU times U times ln A. First, we're gonna solve for, take its U. U equals CL cosecant x plus 2x cubed. U prime is equals negative cotangent x cosecant x plus cotangent x squared plus 6x squared, the derivative of 2x cubed. Then A equals 12. Then follow this formula. Y prime equals 12 cosine y prime equals 12 cosine x plus 2x cubed times negative cotangent x cosecant x plus 6x cubed squared, which is our U prime, times ln A is equal to 12 times ln 12. Now here's our final answer for exponential function. And last, we're gonna solve for a maxima minima problem. My problem is find the dimension of a rectangle with a perimeter of 2000 meters so that the area of the rectangle is a maximum. Let the length of rectangle be x, m the width be ym, and the area be am squared. The problem now endure to finding the value of x in 0, finding the value of x in 0 and 500. A is a maximum since A is differentiables. The maximum must occur at a clip. From 1 we have dA over dx, which is equals to 1000 minus 2x. dA over dx gives dA over dx 0 equals to 0 gives 500. Then A is equal to x equals 0, x equals 500, and x equals 5. X equals 500 and y equals 1000. A equals x equals 0, x equals 500, and the another x equals to 1000. Since a times 0 equals a equals 1000, then a times 1000 equals to 0. The maximum of a occurs when x equals 50. When x equals 500, then the rectangle is square with 4 sides, so that the maximum are 500 times 500 is equals 250,000 square meters. So this is the final answer. And that's all. Thank you.